To be honest with you, the majority of high achievers are going to have abnormalities. Does it mean it's bad? No, it just means it's something that's giving them benefit in some way. So you don't want to try to normalize somebody who is absolutely brilliant, but they fall outside the norm of a normative database.
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. My name is Jesse Lawler. I am your host, and this is the 208th episode of this podcast dedicated to anything and everything that you can do to help the better functioning of your brain, which is kind of the crowning achievement of your full complement of genetic material. We're getting into the holiday season now, a lot of visiting with family on the near horizon, and probably as good a time as any to talk about personal genomics, the brewing revolution in genetic medicine, and also genetic preventative medicine, finding out what your genes can tell you and sidestepping problems before they might occur. We're going to be talking with a doctor who is deeply involved in this work. Dr. Daniel Stickler will be our guest in the main interview. And if you hang around until the very end of the episode, I'm going to tell you about some scientists who are interested in harvesting ideas from the animal kingdom about how to prevent human brain damage from stroke. That will be in the Ruthless Listener Retention gimmick. But right now, let's kick things off, as usual, with This Week in Neuroscience.
Smart Drug Smarts, This Week in Neuroscience.
So this particular study is more about psychology than about neuroscience, but it is so interesting and weird and head-scratching that I wanted to get it in here, and it has a lot to do with that fascinating old chestnut, placebo effects. I feel like placebo effects are to biology what quantum physics are to physics, this puzzle piece that just will not fit in nicely. It certainly doesn't jive with our intuition, even if the data is there to support it. Anyway, so this particular study, as so many studies are, was inspired by an earlier study. Back in 2007, there was a study involving hotel room attendants who completed a 20-minute intervention that told them that their daily work cleaning hotel rooms actually satisfied exercise recommendations and was a lot healthier for them than a job where they might just be sitting staring at a computer screen. And just telling them this over the course of 20 minutes resulted in health improvements for the hotel workers, including lower blood pressure and reductions in body fat and overall weight. So Stanford University researchers Octavia Zart and Alia Crum heard about this experiment. They said, okay, well, if this is good enough for hotel workers, does the same idea hold true over the entire American population? And they tried to see if they could find similar data in large existing data sets. They wound up examining data from over 61,000 Americans who were selected to be representative of the general population. Their information was coming from the U.S. National Health Interview Survey and the National Health and Nutritional Examination Survey, each of which asked participants a broad range of questions about their personal exercise habits, including both nuts and bolts things about how much exercise they actually did, and also more qualitative information like how much exercise the participants felt like they got compared to the average person. And all of these studies on the people's health assessments were over 20 years old. So then what the researchers did was jump 21 years into the future and looked at the National Death Index records to see which of the earlier studies participants had actually survived the intervening time. And the results and what they found are probably more psychologically interesting than they are physiologically. Probably not a surprise, but those people who were more physically active were less likely to have died during the follow-up period. But even after they factored out actual physical activity levels and just looked at the people's perceived activity levels, where they ranked themselves against the average person, people who thought of themselves as less active were up to 71% more likely to die during the follow-up period than those who perceived themselves as more active. This is after accounting for actual physical activity, for obesity, for smoking, for other things that are known determinants of mortality. Just the person's feelings about their activity levels was hugely correlated with their risk of death. Now, as for what the potential mechanisms here could be, the researchers offer a few possibilities. One is that self-perceptions can affect motivation, and that each of the assessments that was made early on was taken at some snapshot in time, and that a good self-perception of activity levels at that time might have led to more actual physical activity in the years following. Or conversely, if somebody felt like they weren't that active, that might disincline them to actually exercise more in the following years. So in other words, this would sort of be a self-fulfilling prophecy argument, saying that their bad feelings about their exercise levels led to actually getting less exercise, and that actually getting less exercise led to earlier death. The other two possibilities that they offer are strictly psychological. One is that perceptions can have emotional consequences. If somebody feels like they're getting less exercise than they should, they might get stressed about that, and the stress could have negative health consequences. And the third possibility offered is, as you might have guessed, the placebo and nocebo effects. The people who felt like they were getting less than enough exercise might have gotten negative effects just based on those feelings. And of course, none of these three possibilities are mutually exclusive. All of them could be working in concert. But a fascinating study really underscores the point that not only is it important to get enough exercise, but it's really important to feel like you're getting enough exercise.
Smart Drug Smarts, the podcast so smart, We have smart in our title, twice.
Picked up a couple of 5-star reviews on iTunes. Listener Lieutenant Huss from Canada said, I just found this recently and have been binge listening. I'm up to episode 114 now. Keep cranking out new episodes so I don't run out. And listener Tracy Moe from the USA says, I love the pace of this podcast. I find myself thinking of a question about the topic being discussed and then I hear my question being answered. It really helps to keep the podcast feeling like a good use of time. Well, thanks to both of you. Thanks to everyone that's been spreading the word. If you know somebody you think needs a little more cognitive stimulation in your life and might like the podcast, definitely drop them a link or casually slip your earbuds into their ears. Probably a little less creepy, a little less likely to get you restraining orders rather than putting earbuds in somebody's ears is to just forward them an email. And if you are a subscriber to the Brain Breakfast newsletter that we do, that becomes a much easier proposition. The Brain Breakfast is our weekly or so mailing list. We cover the good, the bad, the neuroscientific, and certainly the weird. If you want to try that out, you can get signed up at smartdrugsmarts.com/newsletter. It is officially December now, the season of consumerism, and I think they throw in a couple of holidays for good measure as well. There will be things going on throughout the month at both axonlabs.io and vitamunk.com, our couple of supplement sponsors, both of which, by the way, have mailing lists and social media accounts and all the things one might want to sign up for to get first crack at deals as they emerge. There have been known to be flash sales. There have been known to be email-only offers. The Vitamunk launch list, even though Vitamunk has been launched for a long time, they continue to launch new products, and their email launch list is a great way of staying on top of that. They've got a pretty clever velocity building strategy, which I won't belabor you with the details, but it makes their initial launches just shy of being an actual giveaway. They don't make money on those deals. So if you're looking for legit supplements at scandalously low prices, you can get signed up for that list at smartdrugsmarts.com/launch. And at axonlabs.io, we've been doing a bunch of work on the website over there. Haven't quite pulled the veil off yet, but getting ready for a holiday web upgrade. Not exactly sure when we'll be pulling the big Frankenstein lever that takes the new site live, but that'll probably be happening within a week. Confusingly, I know that website does not end in .com, but is at .io. But if you're listening to this podcast, I'm assuming an unusual suffix probably doesn't scare you. So check out what we're up to and fill your friends and family's holiday stockings with Nexus and Mitogen over at axonlabs.io. Last but not least, you might have noticed this episode is exactly 1 week later than you might have expected. Big apologies for running late on that. Last week I was traveling, actually still am traveling, but with travel, the Thanksgiving holiday, finding quiet places to record in, events conspired to make me late. My fault. Figured it was best to just let things slide back exactly 1 week, keep with the Friday schedule. Hope that you weren't worried, but on with the show.
Smart Drug Smarts.
So I'm about to be speaking with Dr. Daniel Stickler from the Epigenetics Center for Human Potential. Dr. Stickler is also the new medical director over at the Neurohacker Collective. We've spoken with a couple of Neurohacker Collective types in previous episodes. Daniel Schmachtenberger, the co-founder of the collective in episode number 169, and Dr. Zach Stein, who's on their scientific advisory board. He and I spoke about the future of education in episode number 181. And Dr. Stickler is a medical doctor who has really gone whole hog on the idea that genetic medicine, the ability to look at a person's particular genetic makeup and also epigenetic makeup and use that as a treatment modality, is really one of the biggest things happening in medicine, maybe the story of the next several decades as far as where the biggest advances in medicine will be seen. His particular interest isn't so much in treating disease, but instead looking at how a person's genetic data can be used to really optimize that person's health. Some parts of this conversation might be a bit hard to follow if you're not caught up on your basic high school biology level of DNA terminology. But if there's one thing that you'll walk away from this interview thinking, it's that the word ome is getting really popular, as in genome, epigenome, metabolome, microbiome, etc. But the ability to study these very personalized data sets and then cross-correlate those with outcomes that we know from other people, this is really on the cutting edge of medicine right now. Everybody's aware of 23andMe and some of these consumer applications, and we'll be talking about what a medical practitioner like Dr. Stickler will do to turn those into a personalized set of lifestyle recommendations. This field, by the way, this doesn't end in ome, is called bioinformatics, the harvesting, information, and use of biologically relevant big data. So gather round and get ready to transcribe some genetic information from Dr. Daniel Stickler.
When people first got their 23andMe data, they were bringing it to me and they were asking me, what does this mean? And I had never seen genetics like this before. I mean, we did not have genetic polymorphisms when I went through training that we understood anything about. And there's not any ongoing updates in the education for clinicians in that realm typically. So it was more of a session with trying to learn it. And the more I got into it, the more confusing it got. One study would say this and the other study would say just the opposite of that. So I said, I've got to make sense of this. And I know this sounds like an exaggeration, but I truly put in probably 10,000 hours over the last 9 years of researching this and kind of started applying it as a hobby in my clinical practice and realized that, wow, this was true personalization of care with each individual. And the realization that we already knew, but now we understand why, is that each individual responds differently to different things. I mean, you talk about nutrition, you talk about exercise, and trying to fit people into a best category for the human race. It doesn't exist. And that personalization aspect is really a critical piece of developing a plan for each individual.
Where are we now versus, say, 10 years ago versus maybe looking 10 years into the future, given what we know about somebody's genetic profile, epigenetic profile, being able to predict these are the types of problems this person might be likely to have, these are the types of strengths that they're likely to have, and what sort of interventions might they really respond to best?
That's kind of a difficult question because we've taken several steps forward and several steps back. Because just recently I was at the Festival of Genomics in San Diego, and we were talking about, there was an article that came out of Stanford that said this data we're getting on genetic polymorphisms is useless. You can't take a single polymorphism and say, okay, well, this means this, like an MTHFR. You say you have a variant of that, it means this. What they're finding is that it is truly a systems biology and a systems-based approach that needs to be taken into account, because you have your genetic code, and the genetic code is fixed. I mean, it's there. And then we have the epigenetics on top of that. Well, the epigenetics can move on a daily basis. I mean, you have a meal of omega-3s, and you're going to change expression of 400 genes. But you take those omega-3s over a 6-month period, and you're going to have change in expression of 1,500 genes in a different way. So the epigenome is so malleable that really using strict genetic data by itself is not of value. Does it say that the genetic data is not of value at all? No, but it's part of the entire systems-based approach to working with people, because you've got to be able to understand. I mean, if you have a traumatic childhood, you can have methylation of the promoter region of BDNF, brain-derived neurotrophic factor, which is so important, as you know, in memory consolidation and learning and things like that, neuroplasticity. So you've got to take into account, well, they may have normal genetics for BDNF, but if they've had a traumatic childhood, they could have had those genes really downregulated based on methylation patterns on the genetics. So it's not a matter of just taking genetic data. I mean, we were all excited about the fact that now we have this blueprint of the human being. And the more we learn about it, the more we realize how malleable this blueprint truly is.
Yeah, it's almost like if the DNA were the blueprint, then the epigenetics are like the specific to-do tasks that the foreman has assigned the workers on site for that particular day of building.
Exactly.
Do we have a way of getting an epigenetic snapshot the way that we do of getting a DNA snapshot, or is that even worth doing because it could potentially change so quickly from one breath to the next?
Well, and that's the big question. Can we map the epigenome? And there's a lot of companies out there that are trying to really get a good grasp on what the epigenome truly does. And, when we look at metabolome, so the metabolic responses, so we're looking downstream even further. So we have the genome, then we have the epigenome, and then we have the metabolome, transcriptomes. All of those, you can look downstream, and there's companies coming out that are saying, okay, we can map the metabolome. Well, the problem is that every cell type in the body may have a different expression.
Right.
It's just like that old thing of checking urinary neurotransmitters to determine what your dopamine level is in the brain. It just doesn't work that way because it's released from so many different areas that you can't say this specifically represents brain dopamine. And the same way with the metabolome, you get into that situation. Now, in the epigenome, you can get a pretty decent idea of methylation patterns on different things by using the white cells, but it's still not going to be exact for the specific regions that you want to analyze. So as of right now, we don't have the best way to utilize that. And I think where we're going here is into these huge bioinformatics platforms, and where you can take all of the quantified self devices and feed them into a process, feed in lifestyle aspects, feed in dietary patterns, feed in genetics. And as we build these bioinformatics databases, we'll actually start to get some solid data that we can use for individuals.
It sounds like since each cell basically has its own set of epigenetic on-off switches, this is always going to be somewhat of a fuzzy process where we can see a correlation between our environmental inputs and our resultant outputs. And we know that it's individual cells' epigenetics that are playing the middleman role there, but because there's however many billions of cells in the body, it's always going to be a bit of a fuzzy system in between.
Yeah, I mean, you're going to have to do some guesswork with it. And that's why when I look at these direct-to-consumer genetic tests, I mean, I don't want to be too extreme with this, but they're not very useful. You see people with like an ACTN3. I mean, everybody who tests athletic performance will test ACTN3. And if you're a CC or you're a sprint athlete versus a TT, you're an endurance athlete. And that is so generic, and yet we still have Olympic sprinters that are TT in that variant. And now we're understanding that what happens is, okay, so that variant of ACTN3 causes a disruption of actinin-3 in the muscles. So you don't have that actinin-3. But now we're seeing that people who train that have that deficiency actually upregulate actinin-2 and can perform sprint very well. So you've got to be able to interact with the person and understand what they've experienced, what they do from a lifestyle aspect, in order to adequately translate genetic data for them in a practical way.
What would be some examples of the types of interventions that you've recommended to people based on their genetic or epigenetic data?
We actually have created our own templates for that, but we only utilize those in our certified coaches. So we use nutritional templates, supplementation templates, sleep templates, neurotransmitter, hormones, detoxification and mitochondrial health, athletic performance. So we have a whole host of the ones that we look at, but we also understand that they're not the true direction that people need to go. So like in nutrition, we'll see people that will say, well, I can't lose weight on this paleo diet or this ketogenic diet, and we look at their labs and they have elevated blood sugars, elevated A1C despite hardly any carb intake. But then we can look at their genetics and we see that they carry insulin resistance genes, or we look at their genetics and they have an ApoE4 on there, it's an Alzheimer's risk gene, but it has to do with the transport of fats, especially saturated fats. So those are people that we would say, okay, well, we need to modify your diet somewhat to say, let's take less saturated fat, let's focus on this. We see people that need carbohydrates in order to lose abdominal fat based on the genetics. Now, that's not written in stone, but what we say is probability-wise, you'll do better by taking in more complex carbohydrates. So we increase their carbs and we see what happens. And typically when they do have these variants, we see that they actually start to lose weight. Their blood sugars get better. It's just an additional biometric. And you want to have as many biometric pieces put together into one place to help guide outcome, but you also want to have ways to measure whether the interventions are working or not, and then step back and reevaluate.
What do you do for that last step for actually measuring whether things are working or not?
Well, we look at their lab work, we look at their biometric data. Most of my clients wear a Fitbit and I monitor it. It loads up into my platform 24/7 so I can see what's going on with them on a daily basis. So if we do an intervention, we say, let's do this dietary change for the next 3 months. And I look at their biometric data, I look at their subjective experience with it, and I look at their lab work. Are we seeing consistency with an outcome that's positive and beneficial for the physiology and the brain? We want to know if they're actually experiencing a better outcome from, an experiential standpoint as well.
Yeah, as much as physiology is obviously important to everybody, it's also quite a bit easier to measure. Sometimes the more ephemeral things of mood and creativity and focus, that's harder to even self-analyze, I think, than, how big is my waistline?
Well, we work with all of our clients. We run through a 18-lead QEEG analysis. We compare it to a normative database, but the person that we have that actually kind of reads over our cues for us, our CEO and myself, we're both trained in reading cues, but we have this one person that reads our cues for us that reads them in a performance basis. She interviews the person who had the cue done, and then she looks at these brain patterns and says, okay, well, are these consistent with what we're seeing in what they're reporting, or is it not? Because, if you look at cues, the normative databases are designed to identify disease states. And we don't deal in disease. I mean, we deal in human optimization. So our clients are the athletes, they're the business executives, or the entrepreneurs, they're the biohackers that want to progress to the next level of function. So we look at the cue, and to be honest with you, I mean, the majority of high achievers are going to have abnormalities on their cue. Does it mean it's bad? No, it just means that it's something that's giving them benefit in some way. So you don't want to try to normalize somebody who is absolutely brilliant in some area, but they fall outside the norm of a normative database. So we assess the cues, we assess psychophysiologic stress profile. So we hook people up to a machine that looks like a lie detector. So we measure their skin conductance, their skin temperatures, their respiratory rates in the chest and abdomen. We look at HRV, we look at muscle tension, and then we take them through stressors, and we see not only what they experience during the stressor, but what happens when the stressor is removed. So we're looking at the resiliency aspect. Then we throw in the genetics, then we throw in lab work, then we throw in body composition scans. So we're looking at all these aspects to say, okay, here's where you are in your current state. We always tell people we don't care where you came from. We care where you are at the moment and where you want to be. So we assess their current state and we say, okay, this is where you are. This is where you want to be. How do we get there?
How long are the programs? Is this typically something that people can make these lifestyle changes over the course of 2 months, 2 years?
Well, personally, what I typically do is we do 2-day intakes. It's about 16 hours of intake with a client. And then I work with them virtually once a month. So once a month, I get on a call with them and I say, okay, where are we now? What's the next steps? We review labs. We review their biometric data. So I'll look at their HRV. I'll look at their Muse. I'll look at their Fitbit data. And we'll kind of assess where they are and are they making progress towards the goal? Because if they're not making the progress, we need to step back and reassess what we're trying to achieve here. And I work with them for a full year. A lot of my clients actually renew after a year, but the minimum is a year of work where we really take a very aggressive approach to say, okay, here's the steps to get there. We found that, when we did every 3 months or, twice a year, the focus tends to drift. And so the once a month seems to be a really good program for getting people focused. And the people who come to me, they're typically people who want to make a difference. In fact, I interview all of my potential clients and I make sure they've got the mindset that they're going to be all in on this, because it's not fun for me to actually work with somebody who's not making any efforts.
For the follow-ups, what would the depth of detail in the follow-up versus in the onboarding process be?
Well, we do some subjective testing. So we have a battery of psychological tests like CNSVS. We have our own health consciousness scale that we use. So we actually look at how are you doing with sleep? How are you doing with stress response? How do you feel subjectively? And then we do some objective measures with memory, reaction times, those kind of things to see where they're moving. And, we'll work with different supplementations. We'll find something in the genetics that says, you have an issue with choline or you have an issue with dopamine, and we'll isolate those things. We'll try different supplementation patterns to see what works best for them and reassess.
CNS-VS, I imagine CNS is central nervous system. Is VS visual system? Is that?
Vital signs.
Vital signs. Okay, gotcha. It's funny, DNA people and military people, it's just acronyms can go wall to wall if you're not careful.
Yeah.
I'd like to talk a bit about individual responses to different nootropics and I guess psychopharmacological compounds in general. There does seem to be so much individual variability. Oftentimes I'll tell people that if something seems safe enough and that is something that they're interested in trying, probably the best route is to just try a little and see what your personal response is, because things do vary so much. The example I always like to give is something as familiar as caffeine. I've spoken with no small handful of people that caffeine makes them sleepy, which of course is the exact opposite of most people. But what can we learn based on looking at people's biomarkers that might give some clue as to how they might respond to different nootropic or cognitive interventions?
Well, the genetics, of course, is where we focus. And especially with caffeine, we can look at different aspects of the caffeine in the genetics. And you have to look at it from a systems-based approach. You can't take one gene and say, oh, well, you're sensitive to caffeine or you're not. Everybody looks at the CYP1A2 genetic polymorphism and they say, well, if you're an AA, you're a rapid metabolizer. If not, you're a slow metabolizer. And that is a pretty consistent one. I see this with people that carry the slow metabolism. Caffeine tends to reside in the system. You're talking about a 5.5 hour half-life, but you can almost double that with variants of that gene. And the other thing is that gene, that CYP1A2, is also responsible for the breakdown of melatonin. So for me, I'm a rapid metabolizer, so I drink probably 12 cups of coffee in a day, and I drink it all the way up until bedtime, and then I sleep like a baby. But what happens is I'm flooding my system with caffeine, so it's competing with the melatonin for breakdown. It's overwhelmed with the caffeine, so melatonin is actually building up in my system throughout the day, even though it's low-grade secretion during the day and peaking caffeine more in the evening, but you're still building it up because it's not getting broken down. And then all of a sudden, I stop drinking caffeine and I rapidly metabolize it. And suddenly there's no more caffeine, but I have all this melatonin in the system that hasn't been broken down yet.
That sounds ideal.
Yeah. So it's great for me. I mean, that's why a lot of these caffeine drinkers who say, I can drink caffeine all day long and I sleep like a baby. Well, we can identify that typically in the genetics. But then we look at things like ADORA2A, which is a gene that looks at how caffeine causes power changes with the EKG in the brain. So it can lead to anxiety. And even if you're a rapid metabolizer, you may still have anxiety issues with caffeine. We can look at adenosine deaminase, which is adenosine in the brain, fills up the adenosine receptors during the day. And that's what kind of turns our bodies down. And caffeine kind of blocks that. But if you don't have a good adenosine deaminase, then you tend to oversleep, and caffeine has an impact on that. So we have to look at all these systems in one piece rather than trying to pick it apart and say, okay, well, you have this, so it means this. It's just like MTHFR. I mean, everybody freaks out about an MTHFR variant, but I've seen what most people would consider really bad variants that would say, oh, you're an under-methylator by 80%, and yet they have normal methylation when we check their methylation status in their blood. So there's other factors that have to be taken into account anytime you're trying to make a decision based solely on genetic data. It just doesn't work very well that way.
It's interesting how there are so many fallback systems that the body gives us for the most important processes, how a single bad allele somewhere is not necessarily the kiss of death. How often do you find what you see in the genetics is sort of contradicted, I guess, by biomarkers like the blood panel? At first might be a cause of worry. You realize this isn't really going to be a problem for this particular individual.
Well, that's kind of a hard question to answer just because of the fact that, I don't look at genetic polymorphisms as good or bad. People tend to say, I have this ApoE4 mutation or this MTHFR mutation. Well, single nucleotide polymorphisms aren't mutations, and people who call them mutations tend to not really understand what they're talking about, because a mutation means that the minor allele has to be present in less than 1% of the population. So in MTHFR, the minor allele is present in 25% of the population. By far is not a mutation. What we're finding is that the alleles that we look at, they are alleles that developed for a positive reason. Like ApoE4s, they tend to get Alzheimer's disease, they tend to get heart disease at an earlier onset and at a higher rate than non-ApoE4s. But people look at it as like this awful thing, but there's actually benefits to ApoE4. There's protection against certain viral infections like hepatitis. There's aspects of better cognitive function in youth. You can process much better with lower energy expenditure in the brain when you have an ApoE4. So what we look at is that these variants occur in a population over the ancestral periods, and we carry these forward, but we move into different environments. So we have allele mismatches for our environments. It's not that they're diseases.
Right. Otherwise, it would have gotten bred out of the population. I mean, anything that's occurring in 1 out of 4 people, at some point there must have been corresponding benefits to go along with the downsides.
Exactly. I mean, it's like MTHFR. I mean, that one's a big one, and they're predicting within 70 years that the minor allele will become the major allele.
Wow.
And because there's a survival benefit of a fetus that carries the, quote, bad version of the MTHFR 677T, because when a mother has adequate folate in her environment, there is a significant survival advantage for the fetus that carries the risk variant. And people who get adequate folate in their environment as they grow, they tend to have less risk for colon cancers. So, there's some benefits that come with these allele variants. So to call them mutations, I think, is really a misnomer on these.
When you've had clients that are mostly interested in improving their cognitive performance versus having a specific physical or physiological goal, weight loss or running a faster marathon or something like that, what have been some of the strategies that you've had for more brain-based outcomes?
Well, most of it is looking at the balance of the neurotransmitters in the brain based on the genetics. And this is a tough area because we have to make a lot of assumptions with this. But we see people with like a COMT variant, and COMT is catechol-methyltransferase, and it's responsible for the breakdown of norepinephrine and dopamine in the brain. We think, okay, well, it'd be great to have more dopamine in the brain. So, a variant that causes less activity of the COMT, you get less breakdown of dopamine. And you say, wow, that would be awesome. Have more dopamine. I'll be happier and all this. But then you got to look at the fact that you're also going to have more norepinephrine. And so people who carry that variant tend to have high anxiety, nervousness, they worry a lot, versus somebody who has a GG, which tends to carry less dopamine. And because they break it down a little bit more aggressively, then they're going to be what they call the warrior type. So they are the ones that are very highly stress resilient, but they also tend to take risks. They're wanting to drive up dopamine. But to generalize that all to COMT is a bit of a problem too. So we look at things like, okay, well, look at the genetics of how many dopamine receptors, the D2 receptors, they're going to have in the brain. We look at MTHFR 1298C, and we look at tyrosine hydroxylase to see how they do with producing the dopamine in the first place. So we've got to look at the breakdown, the production, the receptor sensitivity, the receptor volume that kind of goes into that overall picture. And again, like I said, we're making assumptions based on probabilities with all this, but that's how when we interact with a person, we can tell if we're on target or not with what we're guessing. So I'll give you an example. I had a woman the other day that she had problems with depression, just not much joy in life. She had plenty of dopamine receptors. She had good breakdown of dopamine, but her problem was her production of dopamine was significantly impaired. 30% decreased production based on what we were seeing in the genetics. So we look at that and we say, okay, well, probability is there's not enough production of dopamine because the receptors are there. The breakdown isn't overly aggressive. So how can we boost dopamine levels? So what we did is we looked at using mucuna, which contains L-DOPA. And sure enough, within 2 weeks, she was raving about how good she felt and was wondering if she could take more of a dose. So, it gave us good guidance. But if we had done that and she said, I don't feel any different, then we would step back and reassess ways to actually boost that dopamine. And, a lot of these stacks that people create out there, they look at them and they say, okay, well, this is a good stack for studying because here's 5 different things that boost learning and memory and all of this. But we've got to look from a systems-based approach to say, okay, how do we support each of these systems without overwhelming the system too? Because it truly is a homeostatic balance that you want to achieve. Mm-hmm. Like for me, I have ADD. I have all this alpha activity in the eyes closed state in the frontal lobes that is consistent with an ADD pattern. Now, when I take something like, and this is a plug of somebody I have interest in because I'm the medical director for a Neurohacker Collective, but when I take Qualia, my frontal alpha comes down. Now, it doesn't affect my beta or anything like that. I just see this frontal alpha come down. So it takes my brain into that more homeostatic state. And I experience that in a very positive way. And so we're looking at it and we're saying, well, how is it doing that? Well, it's doing it through, there's 42 different ingredients. I mean, they increase blood flow, they increase precursors, they increase response and breakdown. So it's more of a systems-based approach to boost the areas that may be deficient without overcompensating and kind of taking control over an area, which is, I think, where we make a big mistake with nootropics is that we tend to think, oh, well, this is good for this purpose, so we're going to take that. But you're always going to get some type of compensation in some way that is going to drive that brain to a homeostatic state.
Yeah, it seems like there's a bunch of rival definitions of nootropics. There's sort of the official, original, according to Hoyle version, which is so restrictive that I think very few things could really get over all those hurdles. And then there's the much looser marketing term definition. The one that I kind of personally like and I'm trying to cheerlead for is something that acutely benefits at least one aspect of cognition and then brings you in for a sort of a smooth homeostatic landing, rather than dipping you way below your baselines on some other aspect and kind of having this cognitive oscillation until you can get back to normal.
That's the big crux of it. Do we have a limitless pill? Do we have something that's going to create this? And the answer is that when the brain's in homeostasis, it is achieving that level of limitlessness. You can get that brain into a very balanced homeostatic state where you've got all your pathways and your neurotransmitters balanced. You've got your stress response, maximized for a nice balance between sympathetic and parasympathetic. And the brain opens up at that point to be able to do whatever you want it to do. I've played around with things like modafinil, and we look at genetics to see if you're going to tend to have a better response or not with certain prescription aspects. And modafinil is great, but I get sacrifices in different areas when I use it. So I have better focus and concentration, but I tend to lose emotionality. I tend to lose that sensory aspect of saying, okay, well, this is important or this isn't important.
Yeah, when I've taken modafinil, I've sometimes forgotten to get up and go pee. I'll be working on something and realize, wow, I've needed to pee for the last 3 hours.
Yeah, you've got other processes that need to be maximized, and you tend to get too focused on things. So there's always that balance that you want to achieve. And that's why you look for something that gives you that ability to balance the state. I mean, when we work with somebody, we don't focus on one thing. They say, oh, I want more focus and concentration. Well, first thing we're looking at is their sleep patterns. How's their sleep doing? How's their nutrition? How's their daily movement? How's their exercise? What's their thought processing like? And then we get into more cognitive aspects of it. We look at their stress responses. So the human body, the human physiology, and the human state is a full biosphere. So you've got to take into account every aspect of what's going into it. And the epigenome is the classic example of that. So everything we do is going to change expression of genes. I mean, if you get 4 hours of sleep in one night, you get major alterations in the expression of your clock genes, which throws off all of your organ entrainment clocks throughout the body. And, that's why people are more prone to cancers and diabetes and heart disease when they have chronic sleep deprivation. When you meditate, you meditate for 6 months and you're going to get change in expression of over 3,000 genes in a very positive way. Nutrition's the same way. Olive oil and omega-3s, I mean, they have massive changes in gene expression that over time boost cognitive function, boost energy levels, I mean, across the board. It all comes back to that lifestyle component to begin with. And if the lifestyle component's not there, it doesn't matter what all you're throwing into the system, it's just not going to have that effect.
I'm very interested in people's ability to do mental gear shifting. Like, is the person who has their sleep optimized going to necessarily be able to have their revved up hyper-focused state optimized and then, by the way, be able to drop into a deep meditative state later in the day if they want to? Is it possible to sort of optimize for mental cross-training in that way?
Yeah, we call it the cognitive ninja that can go back and forth between these states. And you give yourself the ability to train that when you have optimized the total biospherical component of the human state. You still have to train that. So bouncing between these tasks, you've got to really practice at that to get good at it. And, just saying that, oh, my brain is primed and I can do this without actually doing the work to get there, it's just not going to happen. It's like meditation. You can say, well, I'm going to meditate, and you expect to have perfect parasympathetic-sympathetic balance after one session. It just doesn't happen. It's just over time, the pathways get shifted. And, this is all about neuroplasticity. So in that kind of situation, what I would say is let's optimize neuroplasticity. So let's do things that are going to boost BDNF in the brain. Let's get somebody on Bacopa. Let's get them on holy basil. Let's get them exercising. Let's get them sleeping right so that we boost neuroplasticity in the brain. Now we're going to train. So we train the processes that we want to achieve. And, there's this state of, and you've heard this, when the neurons, when they fire together, they tend to form networks that can automatically go in. It's like the flow state. Mm-hmm. You have repeated episodes of these combination of neurons that fire together, and then all of a sudden you get this gamma spike, and it's a network that is immediately in place, that they know when this is starting to activate, that we activate all these areas rather than having to try to learn to bring each of the areas in for doing that task. But you have to repeatedly do the task, and you have to have the baseline of optimal neuroplasticity in order to really force the brain into that gamma spike that joins all of these networks into a cohesive pattern that it will recognize when it comes up again.
I guess I'm just really curious as to your thoughts on where we are now versus 5 years from now, like in the transition from VHS tapes to laser discs to where we are now with streaming media. It's like sometimes these things change so fast, and I can certainly understand somebody that's saying, this technology sounds great. It sounds like it's getting there, but it also sounds like it's changing so fast that right now maybe we're still in the Betamax era. I'll wait for a couple more years. How valid is that? Is it worth jumping in now and getting all these tests done, or maybe wait 5 years and see where we're at?
Well, in 5 years, we're definitely going to have significantly more available data. Medicine and health has always gone with, we make the best decisions we have with the information we have at this point. And, you look back at the 1980s, and really half of what we recommended back then, we would say is just crazy stuff now. And so you make the best of what you have information on. And I tell you, genetics is a big deal. I certainly would not hesitate to recommend genetics for everybody. It gives us a baseline guide to really optimal health. It's not the absolute end-all be-all for it, but it's a nice guide. Now, what we're going to see is this transition in medicine from a paradigm of a provider to the paradigm of the AI. And this is probably within the next 5 years. I mean, we already have GoogleNet, which outdiagnoses radiologists and pathologists by 87% to 73%. We have the new Qualcomm Tricorder X Prize, which went to a company that has a portable device that can outdiagnose ER physicians in some cases. Medicine right now is such a algorithm-based practice. Standard of care is basically all algorithms right now. So what's going to happen with it is people will start entering symptoms into a computer and it'll kick out the prescription that you need. And so we're seeing physicians need to start taking on a new role. Physicians, health coaches, chiropractors, whatever. We need to take on a new role as that mediary, that coach that integrates this information for people. The AIs can tell us this thing, but the one thing it won't tell us is that personalized interaction that we're seeing that people will require. So it's great for disease model. The AI will be great for disease model, but when it comes to health optimization model, no, we're going to need the trained clinicians and coaches that can actually help to translate this information into practical application.
Smart Drug Smarts.
So a big thank you to Dr. Daniel Stickler for taking the time for that conversation. I think it goes without saying that the use of genetics and epigenetics in medicine is not going to be going away anytime soon. We're just going to be seeing more and more of that as the years go on. And to the extent that it's possible, getting familiar with the idiosyncrasies of your own genetic information is probably a worthy investment of time and mental resources, especially because unlike most aspects of your life, your genes are something that aren't really going to change too much, at least not without your knowledge and consent and probably a great deal of expense depending on what type of technologies become available in the future. Of course, what probably is likely to change is our understanding of what various constellations of different genes do, which, as Dr. Stickler pointed out, is not so much a matter of pros and cons. There are very few genetic situations that are out and out bad, but either way, with genetic information, probably the more you know, the better off you are. Dr. Stickler's medical facility is called the Epiron Center. Epiron is spelled Apeiron, and you can find him in the contact information for his group at epironcenter.com. And now, moving on, as promised, to how human stroke victims might be able to benefit by stealing a page from the playbook of squirrels, let's jump ahead to the ruthless listener retention gimmick.
Smart Drug Smarts, ruthless listener retention gimmick.
Some things that you learn as you're a little kid that are just explained to you, you don't know anything. The whole world's new at that point, and whatever you learn, you just accept as a given. One of those things is the fact that a lot of animals hibernate. Humans don't, but bears do, squirrels do, a lot of animals do. And it might seem a little bit weird, but you kind of forget how weird it is that these animals that aren't too many branches away from us on the phylogenetic tree, and it's tempting to think that a bear isn't that much further from a human than a bear is from a squirrel. And both of them know how to hibernate, so how come we can't? But isn't it interesting that these animals that don't seem to be too far removed from us are able to go for months without food, water, moving around, going to the bathroom, any of the normal physiological stuff, and then shake it off and go back to life as usual? And some scientists have started recently thinking about just what it is that allows other mammals to hibernate, if some of the underlying processes that make hibernation possible might still be things that we're able to therapeutically bootstrap somehow in a human brain. And if we could do that, what we might be able to get out of it. Some of the researchers who are most curious about this are people looking into therapies for stroke. In the U.S., about 700,000 people experience strokes every year. Strokes break down into two big categories. One is caused by blood clots in the brain. That variety is called an ischemic stroke, and about 85% of strokes fall into this category. The other 15% are called hemorrhagic strokes. That's when a blood vessel actually bursts, which can flood an area of the brain with high-pressure blood. Neither one is good, but the ways that they injure the brain are somewhat different. In the case of the more common ischemic strokes, the individual neurons in the area downstream from the clot are basically starved of the oxygen and other nutrients that they would typically be getting from the blood. And for doctors trying to treat this situation, it's basically a race against time to get rid of the blood clot as quickly as possible and restore blood flow to that area of the brain. So wouldn't it be convenient if when an ischemic stroke happened, instead of the brain cells remaining as thirsty for blood as they normally are in the normal course of business, what if it were possible to put the brain cells into something like hibernation where their metabolic needs dropped way down, which would give the doctors treating them a much longer time clock under which to work? This should really be the goal, according to scientists at the National Institute of Neurological Disorders and Stroke, who believe that creating a fast-acting drug that could make a human brain operate more like a squirrel brain could really be a hugely useful and not unrealistic therapeutic approach. In research that was published in the Journal of the Foundation of the American Societies for Experimental Biology, first author Joshua Bernstock said, "If we could only turn on the process that hibernators appear to use to protect their brains, we could help protect a human brain during a stroke and ultimately help people recover." When hibernating squirrels hibernate, there's something called sumoylation going on, with the acronym SUMO standing for Small Ubiquitin-like Modifier. But this process of global sumoylation is key to helping the squirrel brain handle the rigors of hibernation, which is actually a lot like what they call ischemic stress: reduced blood flow, oxygen, nutrients, everything that a brain normally expects. The researchers found that an enzyme called epsilon boosted sumoylation in the squirrels, and that it could help brain cells survive for extended periods even when they were deprived of both blood and oxygen. Curious if perhaps epsilon was a squirrel-only thing, they tried the same treatment on mice, and adding epsilon to the brains of healthy mice also boosted sumoylation. All this is still a very long way from a human test and a very long way from an actual therapy, but it seems like at least a fruitful line of research to look into. According to the program director, Dr. Francesca Bossetti, for decades, scientists have been searching for an effective brain-protecting stroke therapy to no avail. If the compound identified in this study successfully reduces tissue death and improves recovery in further experiments, it could lead to new approaches for preserving brain cells after an ischemic stroke.
We like to think of ourselves as a digital speakeasy for brain hackers, but you can call us Smart Drug Smarts.
Okay, so that was it for episode number 208. If you enjoyed this episode, you can find everything that we talked about here up online at smartdrugsmarts.com/208. And if you missed last week's episode in 207, I spoke with Dr. Charles Nichols about the scientifically ubiquitous fruit fly, serotonin receptors, LSD in elephants, all kinds of stuff, but mostly about fruit flies. We're probably tapped out of fruit flies for the foreseeable future. And next week, I think we've got another double interview episode in store. Not exactly sure about that, so I don't want to promise anything yet, but the odds are good and we'll get you something good either way. So I will see you back here next Friday for real this time. Same podcast. And with that same unflagging commitment to helping you fine-tune the performance of your own brain. Have a great start of December, and stay smart.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization. Smart Drug Smarts should be listened to for entertainment purposes only. Although some guests on the show are medical doctors, most are not. And the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.